Good morning, everyone. Dear authors and invited guests, welcome to Technical Session 3D. I am Jay Lalwani, moderator for this session. On behalf of Global Knowledge Trust Foundation and Knowledge Chamber of Commerce and Industry, it is my great pleasure to welcome you to the 7th International Conference on ICT for Sustainable Development through Zoom. I hope you will enjoy a knowledgeable and interactive session through the day. There is a special note for the presenters. You will be given 8 minutes for presentation and 2 minutes for question and answer. On 7 minutes, I will raise a gentle reminder. There is another request that you all stay connected with us till the closing remarks. And if you have any query or update, you can write it to me in the chat box. Just before we get started, I would like to introduce you the chair for this session, Navneet Sharma. Dr. Navneet Sharma, he is an associate professor, Department of Computer and Science and IT, IIS University, Jaipur. He has more than 17 years of teaching experience of UG and PG classes. So he is associated with various research association and universities and consultancy services research. His research areas e-commerce, cloud computing, data science and securities, software engineering. He has more than 25 research papers published in various international journals and more than 30 conferences attended all over India. Uh, Welcome, sir.
Namaskar and thank you so much.
Let's start with the papers. So,
Yes, sure.
our first presenter is Deva Devan, and his paper title is Architecture of AI-enabled online education system. Mr. Deva Devan, you may start your presentation. Thank
Yeah.
you.
Yeah, thank you. Just I am sharing the screen.
Yes, sir.
Is my screen is visible?
You can just tap share screen button.
Share screen. Okay. Hope my
Yes.
screen is visible. Okay.
Yes, you can start.
Okay. Very good morning to all. My paper title is Architecture of Artificial Intelligence Enabled Online Education System. This is my research paper. I am doing research at SRM University, Chennai, and myself is the primary author along with my guide, Mr. Dr. Suresh Shankar Narayanan. He is professor. And with this, the introduction is we are using the online education system, which is more than 20 years. We are continuously using the online platform for education purpose. And the rapid increase in the artificial intelligence, this one, now earlier it is only in research stage. AI is in research stage. Now AI applications we are using in mobiles and other devices also. So this can be leveraged into education system platform for more effectiveness and better results. And for every system we need an architecture. So I concentrated on actually my main primary work is some 3 components, that is attentiveness, effectiveness, and question answering, integrating of the 3 components in the online education system. But as a beginning of the research work, there is a need to define some architecture. So based on that, the architecture of the online education system has been outlined in this paper. The proposed AI-powered architecture consists of more features in the form of agents, which are discussed in detail. And in architecture in general, we know that system architecture, we talk about hardware architecture. Apart from hardware architecture, my major concern is software architecture, because hardware architecture nowadays we are using cloud-based services for hosting data centers and other services. So there is whatever we are thinking to data, for example, disaster recovery and load balancing, and for example, increasing the this one scalability and all these things nowadays we can achieve through that cloud services. So it is already discussed. The purpose why I am not concentrating on this one is the most of the researchers already which are carried out are they discussed detailed in hardware architecture. So I felt that there is a need to talk about some software architecture also, because which needs different agents of AI which can be integrated in the online education system. So there is a gap in the architecture that needs to be outlined that integrate various AI agents for intelligent and online education system. This will be discussed. So in the architecture view, the architecture has been in 3 layers I have defined. One is the major AI components, which are going to be the backbone for the artificial intelligence enabled online education system, that is face recognition, speech to text and machine translation and other AI services, which are backbone for the AI enabled this online education system. And after that, we have the common learning management system, which consists of web server, file server, database server, and other servers for hosting the LMS or MOOC, what we nowadays call massive open online, so that is courses for hosting these services. And finally, the end users. These are the 3-layer architecture view. Now that can be seen in this diagram, that is AI services. After that, the cloud-based software or hardware components which are integrated for delivering the online education system by integrating the AI services from the backbone, and through internet it will be accessed by all the users. The first layer consists of common AI services that are directly integrated from the AI service provider, and the second layer is the core of education system, which integrates several AI services as well as techniques for measuring attentiveness, identification of effectiveness, question answering. These are the 3 major components which I am working at present. And the third layer is the end of the end users or learners. In terms of that, when we are considering role of agents in the artificial intelligence powered system, the core components of in addition to the learning management system, actually some additional agents are playing major role. That is AAA agent. The authentication, authorization, and accounting agent is used to provide content access mechanism for authorized users. And resource agent, it is a repository of all the e-content delivered to the learners during various sessions. The e-content includes recorded video lectures, images, text and PDF files, and important links, etc. And content delivery agent, this agent is responsible for adjusting the content of the lecture based on the performance of the learner. Attentiveness monitoring agent. Computer vision is one of the important techniques used to identify effectiveness of learners using that head pose and other facial impressions. All these things will be analyzed. And query generation and effectiveness assessment agent. This agent is intended to generate questions based on the live lectures by identifying important keywords. And analytics agent, this will provide the different insights, that is various reports based on the data captured during the online education system. These are the major part of the architecture of software architecture of the this one. And when I told about attentiveness, we are planning to use that CNN for image processing, object detection, and other things. And for effectiveness analysis, that question answering system will be generated. Earlier, we used to have that chatbots and other discussion forums, which are not directly related with interaction with the faculty or something. So, while we are delivering some lecture, there can be the words can be captured, sentences can be captured, and based on the captured sentences, the important keywords can be identified, and the bet we are planning to implement for analyzing the natural language processing and identifying the keywords and generate the question answers. And we are planning to use squared data set. And this is about my paper. And in conclusion, the proposed architecture is a part of the research work which will be analyzed for incorporating AI services specifically for attentiveness, effectiveness, and question answering to improve the online education system with optimum intelligence. And this architecture will help to future improve further integration of different AI services into the online education system. I hope others are also listening, and I actually reviewed more than 50 papers for my research work. Still, it is going on, and in this place, since it is in initial stage, I would in the paper I have referred only the relevant papers which are related to architecture and the other things, which are 13 papers I included in the conference paper, as well as the paper which I submitted for publishing. Thank you. Any questions?
Yes, any question from the audience? Devadevan sir?
Yes, sir.
I have one question.
Yes, sir.
You have nicely present your architecture, but how it is better from other architectures, as there are so many other AI-based architectures
actually,
are available.
Yes, actually,
So
I
have you compared?
Yes, sir. I have referred one of the architects' paper. Actually, they have talked about the architecture of that online education system only in terms of hardware architecture, sir. How the load balancing will work, how number of users, how they will tackle the number of users when the number of users are increasing, because the online lecture itself is based on huge content of video lectures. So when the video contents are streamed, then their concern is how to use some media server for support of enhancing the seamless content access and all these things. But most of the things are related to hardware only. But in this paper, what I discussed is how we can integrate different AI components for effectiveness and as well as attentiveness, for improvement of attentiveness. Because now I can deliver lecture actually just now I am presenting anyway. But in terms of lecture also, now in the online education system, the major problem is how attentive are others, whether we are online listeners are really listening or not, we are not able to do analyze. That is what in this paper we are concentrating to capture their just through camera their image processing and all these things we are planning. And that is the major part of the research work, that attentiveness, effectiveness analysis, as well as question and answering. The question answering is not like that we will ask like what you are asking and I am responding, not like that. Based on what the content is delivered by the lecturer, that some keywords needs sentence needs to be taken, and based on some sentence, if important keywords are there, that needs to be hidden, and only some question needs to be generated for analyzing whether the candidates are really attending the class or really just they are able to understand the lecture. I may attend, somebody may attend, but they will not listen what is going on, because nowadays this is the major problem in online education. Because I am also from education department, you are very well know about how students are behaving nowadays.
Okay, thank you so much.
Thank you, sir. Can I stop this screen, sir?
Yes, sure.
Okay, thank you.
Thank you, Mr. Devadevan, for a nice presentation.
Thank you, sir. Because time limit is mentioned, that's why I thought I should limit with only this much. Otherwise, maybe. Okay, thank you.
We are calling our next presenter, Ms. Mohini Darji, and her paper title is Review of Deep Learning, a New Era.
Yes, sir.
Yes, you can start it.
Am I audible?
Yes.
Okay, thank you. Myself, Mohini Darji, and I'm doing research under the Dr. Jaikumar Dave, and he is also my one of the paper. So my paper is Review of Deep Learning, a New Era. These are the outlines, introduction, background of deep learning, different applications, yearly analysis of publication, and the conclusion. And I'm doing the research under the guidance of the Dr. Jai Dave sir. And I'm researcher at the Sarkarjan Patel University, and I'm doing working at Charosat University. So this is nowadays researchers use the deep learning models for the any applications. Now they are not using the machine learning models because they're having some loopholes is there. Okay, so they are move forward to the deep learning models. So nowadays this is the new era in our generation. Now all the researchers use the deep learning. Why deep learning? Because they're having that some of the loopholes that in the AI and the machine learning that will be solved with the using of the deep learning models. And another one thing is that in the machine learning, they're having one layer is that with the using of that layer, you have to extract the features. But there is on the in the deep learning, there is only one layer that will be used for the extract features. You don't have to do another one thing. So deep learning made surprisingly progress in a different artificial intelligence, AI, and computer vision application. The learning permits different handling layers to learn highlights without help from anyone else in most of the traditional AI app, which couldn't handle the information in the normal structure. So DL focuses on only two basic elements like non-linear processing in the several layers and supervised and unsupervised learning. So non-linear processing in many layers is a method in which the current layer uses the previous layer output as a input. So we know that and the deep learning neural network, they're having lots of methods is there like CNN, LSTM, all that things. And they have achieved better result in that field. If we are talking about the CNN, it will good result in the imaginary data. And if we are talking about the LSTM, it will give the good result in the predictions. So on the other side, the class target label is linked to the supervised. If the teacher is present, you can say that this is supervised learning. If the teacher is not present in the classroom, you can, if for example, if we are learning from the YouTube videos, that you can say that unsupervised learning. So there are the different applications that are available. In that, the researcher use the deep learning models for the classification, for the predictions, all that things. The first application that is the biometrics. So they are used in the research of biometric traits in terms of security, specifically access the controls. And they have achieved the better accuracy in the form of the biometrics. So using two alternative architecture of deep belief network and automatic voice recognition application was conducted in 2009 to reduce the phone error rate PER. In 2012, hybrid neural network and the hidden Markov model was developed using CNN techniques. So nowadays, they not only using the single models like CNN, LSTM, they have also combined the two algorithms and takes the advantage of the two algorithms and make another one algorithm, and it will give the better result. The deep learning model is also used in the image processing. So couple of utilization has been finished within the concept of exam recognition through layer handling before deep advancing formality came up as another exploring approach. So see, for the image processing, the researcher used the mainly CNN algorithm, convolution neural network, because that gives the better result for the image processing, and it will give the good accuracy in that form. The deep learning that will also use in the medicine lines. Okay, digital image processing is certainly a significant element. So medicine, you can also in the form of prediction, we can say that you can predict any of we can say the human has a diabetes or the any of the diseases that you can early warning of the prediction. It will help to human lives also. Okay. And another one thing is the rainfall prediction is there. So I'm just focusing on in the research and the rainfall prediction based. So lots of researchers have used the ANN techniques, statistical techniques. Statistical techniques, it will give the good result on the linear data, but it will not give the good result on the non-linear data. So now, in the before they have used the artificial neural network and the machine learning models, but machine learning models, but also having some loopholes like it cannot detect the peak values. It also gives sometimes a negative prediction. It also sometimes overfitting problem is also there. These are the problems will be occur with the using of the machine learning models, but deep learning model overcome all that deficiency in the machine learning.
Mohiniji, sorry to interrupt you.
Yes, sir.
Just try to explain the slides, not read the slides.
So that things is not available in that slides.
Okay.
Whatever I have explained right now, just about the statistical models and all that things, this is not
Okay.
available.
Okay. Okay. You may continue.
Yes, sir. So yes, sir. Now before they've used the statistical models, and that will not give the good result for the linear data, but they also sometimes they also use the machine learning model for the rainfall prediction. But machine learning model that also have some of the loopholes is there, like the peak detection. Peak detection issue is there in the machine learning model. Another one that is the negative prediction also is occur. That another one thing is the overfitting problem is also there with the using of the machine learning models. But nowadays researchers use the deep learning models for the rainfall forecasting. In that they have use the different algorithms like convolution neural network, and that they have used the LSTM, long short-term memory, and that they have used RNN, and from that they have compare all that models, and they have conclude that from that thing that this model is comparatively better or not. This is the early analysis of the publication in the deep learning models. So from that, we can see that this is the all the articles about the image processing from 2006 to 2020, 2021. So from that, we can see that on the 2006, the researchers use they just know about the things, deep learning, but they have not used that things. So nowadays, we can see from 2006 to 2012 and 2015, the increasingly the number of increasing in the articles. So they now researchers know about the deep learning, how it will be used, what are the advantage of it, how it is better than the machine learning models. So that will be the researcher use that things in the image processing. We can see the articles of the speech recognition. In that also they have used the deep learning models. We can see the increasing number of in the papers in the from 2006 to 2021. Another one thing is about the rainfall prediction. So before they have used in the rainfall prediction the statistical techniques and machine learning models, and they have not given the good result. So now the researchers know about the deep learning models, how it will be used. So we can see from the graph, the number will be increasing, the count will be increasing, and the count will be increasing since from 2018. It's more than 4,000 papers or 4,000 articles is there. So from that, I'll conclude one thing is that, so okay, nowadays researchers use that deep learning models because the deep learning models overcome the loopholes of the machine learning models. And another one thing is that the feature extraction problem is solved in the deep learning models. Another one thing is the overfitting problem is also that will be also overcome with the using of the deep learning models. But yes, that also somehow in the limitation of the deep learning models, that is you need some large number of the data in terms of you can see the terabytes or the gigabytes. Okay, you also need some GPUs, high number of the GPUs, and the large number of the computers. And these are the reference which I have used to conclude that why deep learning is new era, and why researchers use the deep learning models, not the machine learning models. Done from my side.
Okay, thank you, Mohiniji. You have presented your topic very nicely, but your speed of presentation was very fast.
Extremely sorry, sir. Because
No issue.
yesterday I have the RSC2 and and just that's why.
Okay. So you are doing PhD?
Yes, sir. From the Sakarchat Patel University
Okay.
on
Where it is
rainfall
situated?
prediction application.
Where it is situated?
What, sir?
Where it is situated? University?
Visnagar.
Okay. Great. Um, so
Ram.
can you conclude your work, though it is a review paper? So can you conclude your
Yes, sir. Just I want to
final
work.
conclusion or conclusion remarks related to your paper within 2 or 3 sentences?
Okay. So, why I do this research in the deep learning? Because I want to select one application from that. So, in the form of that thing, I would refer all the research paper regarding different applications like machine image processing, rainfall predictions. In that, I have seen that they've used the different algorithms of the deep learning models, and from that, I have select one application like rainfall prediction, and I have researched on that things. Then in that they have used the CNN algorithm, LSTM algorithms, and the GRU, gated recurrent unique algorithms. And in that, I have seen that the deep learning models achieves the good result than the machine learning models, just because there are some of the loopholes in form of rainfall forecasting. I can say that. So loopholes is the I have said again one thing, peak detection issue is there. So if we are talking about the rainfall of 2001. So 2001 is the rainfall of 0.5. If we are talking about 2010, the rainfall is about in the mm, we can say that 50 mm. So the peak value is there. So it cannot predict the very well with the using of the machine learning models. Another one thing, sometimes it gives a negative prediction also, but it is not feasible. And sometimes overfitting problem also occur in the machine learning models. So is this from these are the defaults in the machine learning models. They have moved on through the deep learning models, and
Okay.
we can overwrite or we can solve the overfitting problem with the using of the dropout layer in this deep learning neural network.
Okay.
And also one problem is the machine learning is that the vanishing gradient problem. That means your weight becomes nearer to 0. So your weight will be multiplied with the input, so you cannot get the better output. And so that's problem, vanishing gradient problem. Also, you can solve with the using of the deep learning models.
Good. Devadevanji, am I audible to you?
Yes.
So be there in the session. We'll continue your topic in detail again.
Yeah, no issue actually.
As you want to say, we can elaborate more on your topic.
Yes, yeah.
So can we link these topics, the deep learning and your AI-based system?
Actually, without deep learning, AI based nowadays, what she is telling now that we are not relying on only that existing machine learning models. If we are only depending on the existing machine learning models, then there is no research. We should explore more things.
Yes, sir. But you can use also hybrid of the algorithms.
That's what deep learning. Without deep learning, we are not going to do anything. So exploration needs to be done in order to improve the performance of the existing algorithms. All these things.
After completion of all the presenters' presentation, maybe if we get some time or the permission from the organization or organizers, we'll continue this topic. So, Jay sir, can we move for the next presenter?
Yes,
Thank you,
sure.
sir.
Our next presenter is Govardhan R. His paper title is Modeling and Simulation on Terrestrial L-band Radio Source Detection from Aerospace Platforms. Mr. Govardhan, are you there? I think he is absent.
Okay, no issue.
Next presenter is Mithula M, and her paper title is Design and Simulation of RF Road for Estimating Slope Parameters of Liquid and in a Finite Volume Reservoir. Then she is also absent. Next presenter is Delna Jose. Her paper title is A Model in Healthcare Cloud for Securing the Data Using for Computing.
Hello, sir.
Yes, you can start your presentation.
Okay. Sir, is it visible?
Yes.
Okay. So hello, everyone. Good morning. So thank you for selecting me to present my paper. So the presentation, so the topic for our presentation is a security model in a healthcare cloud using fog and decoy method. And this is done by, this is myself, Delna Jose, and along with Dr. Swaminathan J. We both done this. So coming on to the outline, we have introduction, research gap, solution approach, proposed method, and summary. So our project is based on securing the healthcare cloud, like from third-party attack. So telemedicine is basically an online meeting with doctors and patients, like medical representatives. So that is what the basic idea of telemedicine. So nowadays, due to the rise of pandemic and all, this telemedicine is emerging. But in spite of that, we can see there is a large data theft is being identified. So the main focus has been given to secure healthcare private data in the cloud using for computing facilities. So the private healthcare data are accessed and stored securely by implementing a decoy technique. So the basic idea behind this decoy technique is to limit the damage caused by stolen data by decreasing the value of the stolen information. So in order to do that, the decoy should be believable. A perfectly believable decoy should make it impossible for an attacker to figure out the data are real or not. So the second concept is the fog computing. So here we can understand there is fog, cloud, and the end users. So fog computing is basically it acts as an intermediate between the cloud and the data. So in the cloud is a huge platform. So the basic idea of fog is that the necessary data are kept inside the fog and it is delivered to the user. That is the basic technique between the fog computing. So the fog node acts as a mediator between cloud and the end user. And okay, that is the idea of fog computing. So coming on to the research gap. So this is an optimized method for data integrity. So we have some available methods of data security, and it is found to be encrypted and decrypted by non-genuine user. So in cloud computing, so it have limitations regarding multiple processor times. The solution is that we included for computing, which can be incorporated with cloud computing, and data concatenation within an image can be implemented. So coming on to the method, we have two types of formats that are concatenated and can be either an image, video, or else the text. So lower bit of an image and higher bit of a video is connected, which can be retrieved using AES algorithm. Here the image video text document is concatenated within an image that the user won't understand the exact data, but can be viewed only as an image. So coming on to the workflow, we have in our proposed system, there are three types of users, that is admin, doctor, and patient. So each users have separate databases for storage. So in patients data health cloud, a decoy and a user verification system is introduced in the cloud computing facilities. So here we have a user requesting data. In user requested data, initially in the first stage, every user is considered to be attacker. So in the user requesting stage, one is requesting the data. So the next stage is our user verification stage. So in the user verification stage, we will be having, we will send a SMS or any user verification. If the requested user is correct, is entering the correct verification code, the original data is given to the this original data is given to the genuine user, and a decoy is given to the genuine user. In the case we enter the right to wrong, we will give the data, but for the original genuine user, the original data is given, but to the non-genuine user, we are giving the decoy, which can be more similar to the original data, so as to mistaken. So, and the next stages, it is within this mechanism is done within the hospitals, since this data breaches or third party can become within the within the hospital. So we have so there will be for example, in doctors case, we will be having a database. Someone else is trying to view that. So we will what we will do is that once the user requesting the data, there will be a private key generation. So in the case of private key generation, if it is a genuine user, he will get it. He should enter the private key, then he will get the requested data. Or else in the requested data itself, we will be having an image. So that image is given to the attacker. This is what it is, the conceptual flow of the proposed solution. So the validation used is that the performance of the system is validated using data sets, images, videos obtained from medical representatives, and AES algorithm is used to encrypt and decrypt, which is saved inside the cloud. And coming on to the summary, as a part, as a part of securing the cloud data mission, it mainly focuses on securing users' multimedia data within the cloud by using fog computing. So to this end, like 2 galleries are generated, the original big data, which is kept secretly in the cloud, and decoy medical data, which is used to mistaken the attacker and is kept in the fog. Also, data is being concatenated with the image that only the genuine user can be able to receive it. That's it. Thank you.
Okay, Dalna ji, am I audible?
Yes, sir.
Okay. So how you are merging both the cloud and the fog computing in your presentation?
In your presentation means fog computing means that it is our servers that we are using. For example, our laptop, like that is considered as a fog computing facility. That means our important and the patient's data is stored. That's what we meant by this fog computing.
Can you show your framework?
Idea. Sorry.
Can you show your framework, which you have mentioned in your slide?
Okay.
Second
okay,
last
I'll
slide.
show. Okay, 1 minute. Mm-hmm.
Next one. Yes. Okay, this one. Yes. Move on to the back slide. Yes. So this is your workflow for your proposed model. Okay.
Yeah, proposed model.
Okay. So where you are incorporating the fog computing in this model?
In this model, actually, we have a user verification. So
This
from
is
that
the generalized
user
process.
verification.
This is the generalized process for the securing of the data. Okay, you are applying the AES technologies and other techniques for securing your data. Fine. Now, where you are incorporating the cloud process and the fog computing in this model.
In this model, we are doing this in patient side. So after user verification, it will check if the user verification is correct. It will go to fog and it will give the data that it is requested, or else the decoy from the fog. That after user verification it comes.
So this verification is on the client side or onto the server side?
It is user verification is done actually in the server side, yeah.
It is on server side.
Done by it is actually the user verification. It can be done from that hospital, but because this part can be used by everyone, this patients and can be done can be done from that hospital server, and also from that server we are taking this.
So when we are taking the data from the data center or the data server or the computer, so when it will be encrypted at user level or onto the server level or onto the cloud level. So once you will transfer the data from a local machine to the cloud or into the fog computing, then how will secure this data?
Securing it is actually based on there's a decoy image also within us. The securing is done that part. Like if the user verification is wrong, the decoy is given to the non-genuine user. The decoy is acting as not sharing the genuine data to the attacker.
So you are basically encrypting the data at the client side only, not onto the cloud.
No, yeah, by giving to the user, that time it is done.
I'm not getting your
Shall I
proper
explain this, no?
justification. Pardon?
So can I explain it again?
Yes. No, as per your title, it's okay. Your presentation is good. Your findings are good. But my question is just how we are incorporating the cloud and the fog computing in this model.
Like a cloud is a big guide, like it is a big platform. Okay, so
At which level?
that,
at which level you are using the security tool or the security aspect in this model? If you are using a local database, you are using the hospital data or any other user data which is available on a local machine or on a local server, and then you are moving this data from a local machine or the local server to cloud through fog computing. Okay, so at which level you will apply this security?
So the thing is that we will be having so many data of the users and all. So it will be saved in that we will take the important data and things that requested by this patients and all in the local server.
Onto the local server. No.
Yeah.
So you are agreeing on this that you are handling the local server for data security. Okay.
Yeah.
So when you will apply this security onto the cloud and the fog, so this is just onto the local server.
Yeah, but we can, but in cloud also, I can understand that we can. There is a storage platform in cloud also. So we can be storing our full data to cloud also. But the thing is that when we directly take it from the cloud, it will take the time. Processing time is more. That's what I understood. So for the in that perspective, I came for computing that technique.
So you are getting the data from the cloud or from the
Yeah.
local server. If you are getting the data from the cloud side,
But
then
for,
you are so the data is in which form? You are receiving the data in the normal form or in the encrypted form?
yeah, while the user is doing that, it is doing that encryption decryption process, and we're getting, because it should not reach into the attacker's hands. That's what the idea is.
So at which level you are applying the security? My question is, at which level you are applying your security in your framework?
The main thing is it should the third party attack should not be occurred. That's the main aim of this project.
Okay. See, this is not your final viva or the PhD viva sort of. I'm just asking, I'm just clearing the things. If you are presenting some paper or if you are producing some model, it should be justified with the title and your work. Okay. So at this time, no issue. You have presented a very good presentation, and your workflow diagram and all the things are very nicely presented. But just for the future or for your further research, just keep this thing in mind. Whatever the model you are producing, it should be justified with your words and the topic which you are mentioning. Okay. Otherwise, you have presented very nicely, and your diagram and all the content which you have used in your presentation are very good. No issue, no doubt. Okay. Thank you so much.
Okay. Thank you so much, sir.
Thank you, Dylan.
Thank you, Ms. Delna, for your nice presentation. Moving on next presentation, Ms. Mayuri Sawar, and her paper title is text-based autoencoder for document image denoising with smoothing.
Yeah, good morning, sir.
Yes, you can start the presentation.
Just a second. Is my screen visible?
Yes.
Yeah. So good morning, one and all. I am Mayuri Sawal and I will be a presenter for this presentation. The topic for my presentation is patch-based autoencoder for document image denoising with smoothing. So this is the agenda for this presentation. And this is our team, which includes all the authors and co-authors of the paper. Now coming towards the main topic of the presentation, as we all know that the old documents as well as the new documents are fragile as they are made up of paper, which make them susceptible to many degradations such as stains, bleed through, pencil strokes, etc. We can store these images, documents digitally by capturing their images. But while capturing the images, as well, some noises are introduced such as low resolution or blurring effect, etc. So the main aim of this paper is to remove those degradation from the image and make the document images as clean as possible. So this is the equation for degradation model. Here X is the original image or clean image. D is the degradation function which is applied on the image, and N is the noise or degradation which is added to the image, which gives the final degraded image. So our aim is to obtain the image close to X from the image Y. Moving forward, our proposed model contains two parts, that is the convolutional autoencoder or CAE used along with the skip connections. So in the encoder part of the autoencoder, important features from the document images are extracted and its feature map is created at the bottleneck. And from this feature map, again the image is regenerated. So we are training our model in such a way that features important to the document image, in this case it would be text features and the special features of the image are extracted and its feature map is created. And from this feature map, again the image is regenerated. So effectively, as we are not considering the noise features of the image, it effectively removes the noise. In between the layers of autoencoder, we are also incorporating skip connections. So skip connection is a connection from one layer to another layer where some of the layers in between are skipped, as seen in the figure. We are using the skip connections to avoid the overfitting and the problem of vanishing gradient, as skip connections allow the gradient to flow through the network without turning some layers. Now this is the architecture of our model. As you can see, there is one input layer, 5 convolutional layer, and 5 deconvolutional layer. The input to input layer is 64 by 64 patch, and the output is of also the same size. Here are some skip connections that are between the layers. There is skip connection from input layer to deconvolutional 1 layer, convolutional 2 layer to decon 3 layer, and convolutional 4 layer to decon 5 layer. Now coming towards the implementation of this model. So to train our data set, to train our model, we needed some data set. And as it is a CAE, which is CAE, we needed noisy and clean paired images. To get the clean images, we use the RVL CDIP dataset. It contains images in different classes such as letters, memo, resumes, etc. Now, once we got the clean images, we also needed the corresponding noisy images as well. So to get those, we added the noise externally. These are some samples of the noise added, for example, pencil, bad photocopy, or drum noise. Now, how did we added those noises? So to add those noises, we have used the Python library called ography. So by using ography, we can add the noises in the 3 phases: ink phase, paper phase, and post phase. Now to get the variation in the data, we have varied the different parameters in the functions so that we could augment our data and get good training for our model. Now coming towards the methodology that we have used. So we have created the dataset of the 300 images, both noisy and paired dataset. The image size is 768 by 1024 by 3. First, we are converting these images into the grayscale images. So the 3-channel image is converted into a single channel image. Then by using the library called Patchify, we are converting these images into image patches of size 64 by 64. So a single image will give 192 such patches of size 64 by 64. And for 300 images, such patches are made. So now this all the patches are splitted into 80:20 ratio for training dataset and testing dataset. Now using the training dataset, we train our model, and testing dataset is used to evaluate the model. Now similarly, for the testing of the model, we have to use the image of same size, that is 768 by 1024 by 3. We are converting this image to 768 by 1024 by 1, which is we are converting it to grayscale image. Then as model is trained on patches, we are converting the testing image as well into the patches of size 64 by 64. So ultimately we get 192 patches of this grayscale image. Then we test these patches on our already trained model. So after the testing the model, we get 192 restored or denoised patches. Now we have to join these patches to form the original cleaned images. So there is one function called unpatchify in the Patchify library. But if we use that function unpatchify, it just simply joins the images, which causes invisibility of the patch borders, which results in a jagged image. So to avoid that, we use smoothing to smoothen the image, which removes the visible patch borders from the image. So let me show the example. So this is the input that we are giving to our model, and this is the output that we get without smoothing, and this is the output that we are getting with smoothing. So here we can see that some lines are visible. So these are the patch lines. So these are patch borders. But here, if we see in output with smoothing, those borders are not visible, as those are removed by smoothing. Now coming towards the results. So to evaluate our model, we have used the metric called as SSIM, which stands for Structural Similarity Index Measure. It measures the similarity between 2 different images. So here we are checking for the similarity between the original clean test image and its corresponding image that is created by our model or denoised by our model. So we have so SSIM value lies between 0 to 1, 0 meaning that there is not at all similarity between 2 images, and 1 meaning that there is more or most of the similarity between 2 images. We tested the we tested same dataset for basic CAE model without any patches or ResNet, and for R model. So for basic CAE, we got the value as 0.6132, and for R model, we got it to be 0.894, which is quite good, which means that our model is giving the results which are closer to the actual clean images. Now, these are some visual results of our model. So it is able to remove the noises such as pencil scribble, printer drum noise, bindings and fastener marks on the paper, and low ink blobs. Now, concluding, I would say that the pipeline that we have proposed, that is using the patches of the images, then passing it to the model of autoencoder along with the skip connections, and then merging those patches smoothly, gives good results for noises such as pencil scribbles, low ink blobs, etc. Now, in order to preserve the contextual information, we do not reduce the size of images in the autoencoder. Hence, there is no much loss of information in this process. Hence, the text from the image is recognizable, and it can be used for OCR as well. Now, these are all the references that we have referred to create the slides. Yeah, thank you. That's it.
Is any question from the other audience? Anybody wants to ask something? Okay, Mayuri, which algorithm you are using for the comparison?
For comparison?
For your proposed enhanced and algorithm and the existing framework?
In existing, there is basic CAE, which is convolutional autoencoder, but we are using skip connections in the CAE. So it allows the gradients to flow through directly through the network, which avoids the problems such as overfitting and vanishing gradient.
Okay. So nicely explained the things, Mayuri ji. All the best for your future endeavors. Any other question? Thank you. Thank you so much.
Thank you, sir.
Thank you, Ms. Mayuri, for your nice presentation.
Thank you.
The next presenter is Anusha R5, and her paper title is Personalized Formative Feedbacks and Recommendation Based on Learning Analytics to Enhance the Learning of Java Programming. Ms. Anusha, are you there?
Yes, good morning.
Yes, you can start your presentation.
Please let me know if you can see my screen.
Yes.
Good morning, everyone. My name is Anusha Arpai, and my research topic is personalized formative feedbacks and recommendations based on learning analytics to enhance the learning of Java programming. These are my co-authors, Mr. Vinayak Hegde and Ms. Ranjita J. Shastri. So these are the contents of this presentation. Coming to the abstract, especially during this COVID-19 pandemic, in particular, e-learning has gained more and more popularity. To be effective in online and hybrid learning environments, students must develop self-regulation skills and self-directed learning. It is possible to assist the students in managing their learning process by self-evaluating their performance and through external support and supervision in online learning environments. For this particular study, we have used 69 undergraduate students who participated in a quiz that we conducted on various programming topics. The objective of our project is to trace students' performance by giving them formative, personalized feedbacks. And the secondary objective is to provide recommendations for further improvements based on the continuous assessment. So coming to the introduction, the Union Cabinet, as we all know, has approved the National Education Policy 2020, which intends to use artificial intelligence and machine learning to personalize and adjust learning to the needs of the user. As a result, the application of learning analytics in higher education is gaining more prominence. Learning analytics is nothing but gathering, evaluation, and recording of information on learners and learning environments and circumstances in order to better understand and optimize learning. So according to several studies, one of the most effective strategies to improve the learning process is to provide appropriate feedback at the appropriate time. Following the feedback, it is vital to give certain recommendation materials so that students who are weak in certain areas, that will help them to improve their performance. Finally, it will help them to bridge the gap between the present and desired performance. So for the data collection, we have used Google Form tools. The students were challenged on variety of programming topics. As you can see in the table, these are the topics that we have covered in the assessments. Each of the topics had 7 questions each and 10 marks associated to each of the topics. The topics were divided into 2 tests, basically. Each test was conducted on 40 marks. So it was a total of 80 marks. Coming to the implementation, the personalized learning management system, as we call, is an environment that provides personalized feedback and recommendation to novice programmers. It was developed on XAMPP server using Python and using a MySQL database. This is the homepage of our implementation. And this is the login page. This is the dashboard of the learning management system. Here it depicts the scores of the learners that are collected, analyzed, and stored in a database by the personalized learning management system. Here it basically divides the marks into topic-wise results, and it will give us a clear picture of how is the performance based on the topics, as you can see the graph. So this is the feedback model. And here, based on the student's performance, each of the marks will be given a feedback. So coming here, if the student has scored 8, it seems like the performance is excellent. So we give them excellent performance. And if the student is weak in some areas of the test, then we give them poor performance and average performance based on all of these individual marks. We've used KNN algorithm to predict this, and the accuracy of this algorithm is 87.5 that we have got. And coming to the recommendation, these recommendation videos are based on the feedback that is given to the students. So suppose the student has got lesson, conditional statements, and classes and objects, and some other topics here. So only those topics videos will be recommended to the students so that they can just go through the topics once more and get more clarification on that. So we have used decision tree to give this recommendation videos to the students, and the accuracy of this algorithm is 85.42%. And future of study may be possible to use the same personalized learning management system to administer the tests, and findings should be favorable regardless the subject. Here we have considered only Java programming, so we can incorporate different subjects and different languages as well. So that is the future study, and the current research was carried out, as I told. And coming to the conclusion, in the study, it was aimed to evaluate learners' Java programming skills and provide individualized recommendations and feedback based on learning analytics to assist them in developing industry-relevant skills. Personalized feedback and recommendations have been found to be advantageous to pupils and have yielded positive results in all study trials. The precise personalized feedback and recommendations provided in the study helps the students to bridge the gap between the actual and intended results. So these are the references. Thank you.
Thank you, Anusha ji. You have nicely presented your topic. One question from my side. Before that, any other question from the audience who are available in this online session? Anybody? Nobody wants to ask something? Okay. So, Anusha ji, there are so many LMS are available in the market now after pandemic. Okay, so how you have compared your framework with the existing LMS? How it is better? Can you explain it?
Yes, sir. So here we have given the precise feedbacks and precise recommendations to the students. So as I've seen, the marks that we get, like it is basically for 40 marks. And if we score 35, we know that we are average or we are poor or whatever. But here we are just dividing it into topic-wise results so that the students will get a clear picture of which area they are weak in. So that is one thing that we have done here. And based on only the areas that they are weak in, only those video recommendations are given to them so that they can concentrate more on the topics that they are weak in. So this is one thing that we have done.
Okay. You have chosen the Java programming for this learning-based process. So is there any specific reason behind it, or it's just as an example?
It is just as an example, sir.
Okay, so we can take some other non-computer papers also for
Yes.
the feedback process?
Yes, that is the future study of this research.
Okay, okay. Nicely presented, Anusha ji. Thank you,
so
and
much.
all the best for your future endeavors.
Thank you so much, sir.
Thank you.
Thank you so much, Ms. Anusha, for your kind presentation.
Thank you so much.
Moving on, our next presenter, Ms. Ranjita, and her paper title is Predicting the Grade by Exploring the Relationship Between Computational and Thinking and Academic Performance Through Learning Analytics.
Yes, sir. Good morning. I'll share my screen. Can you see the screen?
Yes, you can.
Good morning, all. I'm Ranjita Jayashastri from Mysore, and my paper is predicting the grade by exploring the relationship between computational thinking and academic performance through learning analytics. And my co-authors are Mr. Vinayak Hegde and Ms. Anusha Arpai, who just presented now. So as you can see, my work and our work is correlated between this work and Anusha's work. So these are the contents of my presentation. So the primary objective of our project is to explore the relationship that exists between the computational thinking and the academic performance of the student. And the other objective is that the grades of the students are to be predicted using computational thinking ability and the academic marks that are scored by applying machine learning algorithm to analyze them. So coming to the abstract, so this study primarily investigates the students' performance, which is like exploring the relationship between computational thinking to determine their academic success, whether it is related to that their computational thinking and their performance in the academics. So for this, as my friend mentioned, over 69 students have been participated. So since it is a pandemic situation, our research has been conducted during the pandemic situation. So we just conducted for undergraduate students of our college only by conducting 2 assessments on Java programming language through Google Forms. So for this, we have just created a user-friendly interface. So in which the previous work is all about the student module, and our work, this work is all about the admin module, which will be like loading the students' marks and the assessments that they have been taken for. So for this, we have applied 2 of the algorithms, that is k-means and naive Bayes. So yeah, by considering our research. So first thing we just considered is what the factors that are affecting any student's academic performance. So that it might be regarding the student or teacher or family or school. These are some of the factors. So it might be, when it comes to student, it is like interest in the subject, self-motivation, communication, punctuality in attending the classes. So when it comes to teacher's alertness, teaching style, learning material, guidance, and also the feedback also, it includes the feedback also, which the last proposed work includes. And also the family background, like family stress, it might be parents' education, economic condition, guidance. And coming to school is like environment and learning facility. These are all the factors that might affect academic performance. And also our proposed work is to see that, including that, the computational thinking of that particular students also affect the performance of the academic performance of that particular student. So for all these work, the main source of this work is that NEP 2020, so which is mainly emphasis is given on the skill-based learning. So in today's competitive world, we all know that the emphasis is given on the algorithmic thinking, mathematical thinking, and all sort of machine learning techniques, and most of the things are in this competitive world we have based on AI thing, and most of these topics. So we cannot just be narrow down our way of learning into the conventional way. So as our contemporary education system has proposed the idea of skill-based learning, so this work is the base work for the education system that is proposed. So for the data collection, as the previous work is given, the same assessment is given for the students among them, and then these are the topics that are covered, like so the number of questions in each topic was 7 and the marks was 10, so totally 80 marks. So for the implementation, this is the login page. And then coming to the admin module of our work is that this is where the bulk data is being loaded. So since I have mentioned that our data is, we have conducted the test through Google Forms. So we are just loading that Excel file, and then we are getting the performance of the students. We are pre-processing the data, and the performance or the marks is displayed based on the topic wise. So then these are the topic wise test 1 and test 2 results. So this is overall marks that are taken from those particular students. Then here we are fetching the topic wise performance of the student. So we have just applied in a clustering algorithm here, that is k-means algorithm to this. So it is fetched so that the most the high performed student are being displayed here from starting and then going to the lowest one in the particular respective topics. So coming to the grade result. So as I mentioned, we have just predicting the possible grades that student get in the particular subject. So for this, we have used Naive-Bayes algorithm for prediction, and we have got 84.54% of accuracy. And here we are getting the students grade, like we have just considered O, A plus A, B plus B, so like that. And regarding that, we are getting the grades there. So coming to the future work, as I'm mentioning that this is the base work of the contemporary education system. So it needs so much of attention to this in order to improve. If it is improved in all these aspects, like considering bigger number of students, obviously, like we had the limitations of COVID pandemic situation, so we couldn't get that much of students. And also we have just considered the students who are learning the Java programming in their academics only. So, and then this can be furthermore given, like the assessments can be given in the other programming languages also, as mentioned by Anusha. And then test can be we have conducted our tests in Google Forms. So in the future works, maybe we can just conduct here only in our interface itself, and a bit more proctored. So as we all know that we have been gone through all these situations in our learning phase, in our during our degree days or something during the pandemic. So much more proctored maybe will be just to get the exact findings. So these are about our thing. So these are the references, and thank you.
Thank you, Ranjita ji. You have presented your topic very nicely.
Thank you, sir.
As you are working on the prediction model, na?
Yes, sir.
So which existing prediction model you have referred for your purpose?
Naive Bayes, sir.
Navy Bayes. And why this only?
When we just looked into the past findings, and that is done by other work, like during the literature survey, we got to know that the much more precise result can be get from the Naive algorithm. So we thought of applying that. So even we had the chance to create our own interface, right? So we thought of getting that from the literature survey, which best suited for our work.
Okay, thank you so much.
Thank you so much, sir.
Thank you so much, Ms. Rajinta, for a nice presentation.
Thank you.
Let's go to our next presenter, Mr. Sachin Gupta, and his paper title is The Changing Landscape of Identity and Access Management with Blockchain-Based Self-Sovereign Identity. Mr. Sachin.
Good morning, sir. Sir, myself, Monica Chawla. Dr. Sachin is my guide, and I'm the research scholar under Dr. Sachin Gupta. So I'll present the presentation.
Okay.
My voice is audible, sir?
Yes. You can start.
Okay. The topic of my presentation is the changing landscape of identity and access management with blockchain-based self-sovereign identity. First of all, I will explain the three models of digital identity. First is siloed or centralized identity model. It is the model with almost all identifiers and credentials, government ID numbers, passport, ID card, driving license, Facebook logins, etc. The centralized models is also the original form of internet identity. That is, you can establish an identity by registering an account with example to typically a username or a different password with a website service or application. For this reason, it is called the account-based identity. For example, the relation of an individual to a website under the internet original centralized account-based identity model. Second is the federated identity model. In this type of model, the identity industry developed a new model called a federated identity. The basic idea is simple: to insert a service provider called an identity provider. That is, one can access with the help of an identity provider. So if we shift on from the centralized or federated model to the self-sovereign identity model. Here, the centralized or federated model, the locus of control was between the other parties who makes the decision about me. But in SSI, the user is put into the center of his or own locus of control. So in self-sovereign identity, it is made up of claims, proofs, and attestation. A claim is an assertion of identity made by the user. Proofs are the forms or documents that acts as evidence for a claim. So, for example, a proof could be a passport or a birth certificate. An attestation or validation is when the other party validates the claim is true. Attestation can be stored in the user device and are typically machine readable. So in self-sovereign identity, first of all, we have to use the decentralized identifier, or we have to verify with the help of a verifiable credential if we are offline. But to countersign it, to add a signature to a document already signed by the another person. For example, a claim issuer signs claim publicly available on a blockchain. Claim holder use a wallet to countersign the claims, and a claim verifier uses signatures available on the blockchain to verify the claims. So in self-sovereign identity, a paper credential you receive is digital as well. So digital credential is given to you and not provided by a third party. It is you who shows it to the others. For example, a driver license claims are accumulated and held by you only. You are the can store any claim that you want in your wallet. The claim verifiers are able to choose what claims they trust and request those from you. Since you hold your private key, you can prove to the verifier that you are in possession of the private key that goes with the claim. So Sarah, there are some basic features of self-sovereign identity which one can understand, that is it's persistent. An identity that can be taken away is not self-sovereign. Identifiers are long-lived, non-reusable, and owned by the person who creates them. Organizations and connected things also need them and can use the same infrastructures as well. Peer-to-peer and not client-server. Privacy protected, portable, and interoperable. For example, inspection sticker, license plate, etc. So the no more username and passwords are required. That is, every relationships you have is separate and a unique username and password. Compare with this, you pass your own single phone number. A single phone allows for correlation. All the credentials sharing occurs of the ledger on the this scales wells. Once you have a credential from the bank, you have no longer a username and a password. To log in, just provide the credential. You can prove you're associated with the private key. So with the help of digital identifiers and verifiable credential, we can improve onboarding new customers becomes fast. Each of your customer has a secure direct connection to you. You can check that each customer is genuine. No more IDs and passwords are required. No more fraudulent card payments. You can send each customer a verified digital receipts. So with the help of blockchain, we can pursue for SSI. In order to implement self-sovereign model of identity, one technology that has risen to the top of the list is the distributed ledger technology. A distributed ledger is a database that exists across several locations or among multiple participants. Blockchain is a sequence of blocks which holds a complete list of transaction records like a conventional public ledger. That is, a blockchain is a basically automatic set of blocks linked together containing a different data structures. Second is identity and access management. In the traditional system, the existing authentication process of KYC is complex and quite expensive. Identities must be portable and verifiable anywhere, anytime. They need to be private and secure. The functionaries in healthcare zones required, like in hospitals, clinics, doctors, pharmacies, and insurance may be intervened properly on the operational front to other prompt and other efficient healthcare facilities for patients. So also in education structure should be systemized and equipped with a robust authentication and verification process. The life cycle of identity management includes a 5 steps process, that is registration, authentication, authorization, provisioning, and deregistration. The registration and deregistration operations are one-time events, while the other 3 runs as the need during the service provisioning phase. The identity management is also referred to in the literature as known as identity and access management. The functions performed by identity and access management includes the changing user roles, monitoring user activity and behavior, general reports on user activity and behavior, and application of access policies. There are various use cases in healthcare. For example, it complete the control of the patient over the sharing of identity information, absolute assurance of privacy protection, consent of the patient in any case of personal information exchange is mandatory, immutability of blockchain ensures that the records can never be tampered with. So in the last but not the least, the further research in the interaction between the decentralized identity mechanism, self-sovereignty, and zero trust model shall bring in the best of decentralization, user authority of data, and minimal disclosure together, and shall remain an interesting field of potential work ahead. The verification in blockchain becomes very fast and easy as all the blocks are verified and the data structures present in them. All the, in the last, we can say that in all the information is decentralized in self-sovereign identity. So there are various references I have used in this paper, and I'm working on this paper. The last, thank you.
Thank you so much, Monica ji. You have presented very nicely the concept of blockchain. One question, just give your answer in the brief.
Right.
What is your specific contribution towards this blockchain verification process?
My personal
all the things are mentioned in the blockchain concept itself, but what is your specific contribution towards this paper?
My contribution towards this paper is 80%. 80% I have written this paper, and my guide suggested me in the various use cases in health, which is in the healthcare department. As I'm pursuing, I told you that I'm pursuing a research under him.
Okay. Okay, thank you so much.
Okay, sir. Thank you.
Thank you so much, Ms. Monica, for a nice presentation. All the presentations are done. So before closing, I'll call our session chair for say some few words.
Thank you, Jay sir. Thank you, Jay sir. So in this session, total 8 presenters present their papers. Mr. Devan presented the first paper. Then Mohini ji, Mridula M, Delna Josh, Sonal ma'am, Anusha ji, Ranjita ji, and Monica ji presented their papers very nicely, and they have presented all the specific topic towards their research contribution in the research fraternity. So all the best for their future endeavors. Hope they will do more research in their specific topic. And from my side, I just suggest few things. When you are giving your presentation, first thing is be confident and use the specific we can say the literature or the content, whatever you are showing on your presentation, you should be more confident on that topic. Secondly, we have so many infographic tools nowadays available. So you can make your presentation more specific, more attractive with the help of these infographic tools. Even we have so many online open source tools. So not be restricted on the PowerPoint presentation only. We can use so many other online tools for illustrating your data, for showing the graphical representations on your topic, and you can summarize the large contents on in the summarized way using these tools. So normally we can use the Canva, Visme, Infogram, ASIL. These are some common online tools which are available, freely available. These are the open source softwares. You can make your presentation more specific and more impressive with the help of these tools. So thank you so much for giving me this opportunity. Thanks the GR Foundation team, Jaji, to invite me for this session. Thanks Amit ji and their team, and all the best for the grand success of this international conference, ICT4SD. Thank you so much.
And sincerely thank our authors for their excellent presentation in this session, and all our authors for being a part of this international conference. I hope this session was informative enough. We on behalf of whole team, thank you for support this version and the previous 6th version of this conference. And we'll happy to have you in 8th version in 2023. All the authors would be getting their digital certificate through email within 2 working days. Further, all the papers are already forwarded to the Springer. Kindly cooperate with the team of ICT4SD 2022. And in the last, I will thank our session chair. Sir, this is a token of appreciation on behalf of Global Knowledge Share Foundation and ICT4SD. Thank you for your valuable presence.
Thank you so much for the entire team.
And the last, I will request all presenters to turn on their cameras for the quick snapshot for the memory of the virtual conference. Please turn on your cameras. Thank you so much. Take care all. Stay safe.